Ever wonder why your phone's navigation app can find a route in seconds, but an AI robot might get stuck trying to move a box across a room? It's not because the robot is dumb. It's fighting a hidden battle against something called symmetries. Today, we're diving into a breakthrough that's helping AI think more like humans, and why this matters for the future of smart machines. Let's start with a simple example. Imagine teaching a robot to navigate a room. You tell it, move the red cube from the table to the shelf. Now, what if you switch the cube's color to blue or rename the table platform and the shelf rack? To us, it's the same task. But to a traditional AI, it's a completely new problem. Why? Because it's stuck focusing on labels, not the actual logic. This is the crux of the issue. Symmetries, hidden patterns in problems that humans see but AI often misses. Here's where things get tricky. Most AI models, like those behind ChatGPT, are built on transformers, powerful systems that process language and data. But transformers are symmetry-aware. They treat every input as unique, even when it's just a renamed version of the same problem. Think of it like a kid who memorizes a puzzle's exact piece positions, but can't solve it if the pieces are shuffled. This leads to a combinatorial explosion. The AI gets overwhelmed by label variations, making it terrible at generalizing. So how did researchers crack this code? They developed a symmetry-aware training approach that teaches AI to recognize when two problems are fundamentally the same, even if they look different. Imagine training a model to see that red cube and blue sphere are just labels for the same concept. They did this using contrastive learning, a technique that pushes the model to group similar problems together, like teaching a child to see that dog and puppy are related. By aligning the model's internal thoughts, its attention scores and hidden states across symmetric inputs, it learns to ignore irrelevant details and focus on the core logic. But they didn't stop there. The team redesigned the transformer's architecture. They removed positional encodings, the math that forces the model to remember where tokens are in a sequence, and replaced them with a more flexible system. This let the AI handle variable names and rearranged inputs more naturally, like a chef who can follow a recipe without getting stuck on the exact brand of flour. Now let's look at a real-world case study. Imagine a robot navigating a grid of rooms, tasked with visiting every cell. Sounds simple, right? But here's the twist. The robot's AI, called PlanGPT, failed completely when room names were randomized. It was relying on meaning, like thinking room 23 is different from room 45, instead of the actual rules of the game. It's like solving a puzzle with scrambled labels. The AI collapses because it's stuck guessing, not understanding. The breakthrough: anonymizing the room names. Think of it as giving the robot a fresh start. No hints, no shortcuts. Now the AI has to figure out the rules of the game from scratch, just like a human would. If you rename blocks in a puzzle or shuffle the grid, our system still works. It's not cheating, it's learning the real logic behind the task. How did we do it? We used a transformer, the same tech behind chatbots but with a twist. Picture a team of workers, each focusing on different parts of the problem. We also trained the AI on diverse scenarios, not just repetitive ones. This helped it adapt to new situations, like a robot learning to navigate a warehouse it's never seen before. The results? In complex domains like gripper, robot moving balls between rooms, and logistics, delivering packages, our model outperformed previous systems, especially when problems got bigger and more complex. It's not about speed, it's about generalization. The AI isn't just memorizing answers, it's understanding how to solve any problem in its domain. So why does this matter? AI planning isn't just about crunching numbers, it's about context. By avoiding shortcuts and focusing on real rules, we're building smarter systems. Whether it's a robot organizing your home or a self-driving car navigating traffic, the future of AI depends on models that think, not just guess. Remember, every breakthrough starts with asking the right question. What will AI learn next? Let's find out together.